Hello, this is Mr. White.
And Mr. Curvis.
We are going to talk to you today about matrices, more specifically solving systems of equation with matrices, and even more specifically how to do it in your calculator. So Mr. Curvis, how do we get to this matrix menu that I've got up here?
You can see you hit this blue button, which is second or whatever color, and then above it is the written in matrix in blue.
So from the main menu,
matrix
just like that.
Alright. And we've already set this one up, so if we went over to edit and pressed enter, then we could make it a 3-row by 3-column matrix, and then we put in all the values.
Yeah.
So we've done that already.
Okay, and same we did for part B and C, we did the 3x1 matrix as well, which you'll have to do. Oops.
Okay. So now, to find the inverse of a 3x3, we can use the GDC. For a 2x2, you have to use your GDC or your formula booklet. But we simply enter the matrix, go to matrix, choose it.
Oh, whoops. Didn't choose it, did I? To choose something, it's just in the names. If you want to change something, you go to the edit. If you want to do some math with it, you go to obviously math. And if you want to choose it, you just pick pick name. Okay. So then we want the inverse, which is this. Okay. These are all in decimals. If you like fractions, you can just go math fraction, and it'll convert all those entries into fractions. Okay. So we won't write the whole thing down, but there's your 2 points right there. 1/10 and everything else.
So there's your A inverse for 2 points on your exam. So in part B, we're now given the system and asked to express it as A, X equals B, where A, X, and B are matrices.
Good. All three of these are matrices. X is your variable matrix. So we should have, and if you notice that this matrix and this matrix, or this system and this matrix are linked, which is not uncommon for IB. You can see right here 1, -5, 3, 1, -5, 3. Okay, so same matrix within this system. So we have to pull out these coefficients of the variables to make this happen. So we should get 1, -3, 1, 2, 2, -1, 1, -5, 3 times, how does this go again, Mr. Green?
X, Y, Z.
Okay, I think he meant X, Y, Z. And 1, 2, 3. Okay. All right, now what?
So once you've got your system set up, that's all that it has for in part C, or sorry, in part B. So we're now moving on to part C, which is the solve.
Okay. So the solving, again, they're leading you through something. So the solving of an equation, of a matrix equation like this, AX equals B, is extremely similar to just solving a regular equation. So let's run through an example with you. We could have something like 2x equals 6. So in order to solve this equation, I usually just divide by 2. But I can also multiply by 1/2, which is the inverse of 2. And I multiply both sides by 1/2. So then this goes away. I'm left with 1x equals 3. And it's solved. So it's the same sort of thing. We multiply A inverse on both sides. So those become the identity. And then we multiply A inverse on this side. Make sure that you always do x equals A inverse times B in this order. We have to do that order. Is that right, Mr. Curtis?
Well, anytime you multiply matrices when you have an equation, remembering that multiplication of matrices, the order can change your result. So if you're going to multiply A inverse on the left-hand side, you have to do it on the left-hand side as well. And on the right-hand side, then you can do it on the right-hand side as well. So depending on how you've got things set up.
Yeah. Okay, so how do I do this thing?
So let's get rid of that green text there, just below. And give ourselves some space. No?
Like that?
And then we can, no, oh sorry. Anyway, now we can go over to the calculator.
Yeah, okay.
And just you find matrix A, already entered, take its inverse, multiply that by B, and enter.
And there we go. If you want to impress your examiner, throw some fractions at them. I love fractions. So, like we said, always x equals A inverse times B, which is this same order that we have it. And in this case, x equals 6 over 5, 3 over 5, 8 over 5. And what is that point? What are these values actually?
Those values are the solutions, or they are the values of x, y, and z that satisfy the three equations that we've been provided with.
Yeah, okay, good. Good luck.